compound of sulfur contains 2.4% hydrogen, 39% sulfur, and 58.6% oxygen. Find the empirical formula for the compound. Okay, let's highlight some of the key information here. 2.4% hydrogen, 39.0% sulfur, and 58.6% oxygen. Let's write that information down. Hydrogen, 2.4%, sulfur, 39.0%, oxygen, 58.6%. Now I'm going to be doing some calculations that involve just hydrogen, just sulfur, and just oxygen. So what I've done is I've split my working up into 3 columns to make that a bit more clear. So in chemistry, usually we don't work in percentages. Sometimes you might be asked to give an answer as a percentage. Sometimes you might, like here, be given some percentages to start out with. But usually in chemistry, especially when we're looking at ratios of atoms in a compound or ratios of compounds or elements in a chemical equation, we want to work in moles. Moles is the key unit here. So we want to get these values to moles somehow. And at the moment, they're percentages. So to get them to moles, though, we have to do a little bit of thinking first. We have to approach this a little bit sort of in a unique way. Think about this a different way. Let's assume for a second, we have 100 grams of the compound. If I assume we have 100 grams of this compound containing sulfur, what does that mean? That will therefore mean that 2.4 grams of that 100 grams is hydrogen. It would also mean that 39.0 grams of that compound is oxygen, and it would, is sulfur, and it would mean that 58.6 grams of this compound is oxygen. Now, let's have a bit of a think. Why did I use 100 grams? Well, I used 100 grams because of 100%. If I didn't use 100 grams, I would have to then do another equation to work out, let's say I used 80 grams, I would have to work out, hey, what's 58.6% of 80 grams? And I'd get a slightly different answer here. The reason why I used 100 grams is because it's just straight cross. I can go straight from percentages to grams, which is a little bit easier for me. So now let's have a look what we've got. We've got grams. Now, that's still not moles, but the thing is I can convert grams to moles. I convert grams to moles by using N equals M over M. I'm going to start with hydrogen first. So how many moles of hydrogen do I have? I have 2.4 grams of hydrogen, and I want to divide that by the molar mass of hydrogen. So let's go up to our periodic table. The molar mass of hydrogen is 1.01. So the number of moles of hydrogen, if I go over to my calculator, is 2.4 divided by 1.01. And it's equal to 2.3762 mole. Let's do the same for sulfur. So the number of moles of sulfur is equal to the mass divided by the molar mass. The number of moles is equal to the mass, which is 39.0 grams, divided by the molar mass of sulfur. And the molar mass of sulfur is 32.06. Let's go with my calculator. 39.0 divided by 32.06. That's equal to 1.2165 mole. And let's now do this for oxygen as well. Number of moles of oxygen is equal to 58.6 grams. Oops, sorry, I forgot my equation. Number of moles is equal to mass divided by molar mass. The number of moles, therefore, is equal to 58.6 grams divided by 16. 16.0? 16.00 grams per mole. So let's go and do this calculation. 58.6 divided by 16.00. Number of moles, therefore, is equal to 3.6625 mole. Great, so now we've got the number of moles of hydrogen, the number of moles of sulfur, and the number of moles of oxygen. So theoretically, I could sort of almost finish that. I could write down this equation, the ratio of hydrogens to sulfur to oxygens is this. I could say my answer is it's H 2.3762, S 1.2165, O 3.6625. And I could say, hey, there's my finished chemical formula for this compound. Now, hopefully we all know that we can't write chemical formulas like that. We can't have 2.3762 atoms of hydrogen, we can't have 1.2165 atoms of sulfur, and we can't have this number of oxygens. So that's not right at all. What we need to do is we need to get these values to a whole number. And what we're going to do is, to get these to a whole number, is we're going to divide each of them by the smallest possible value. By the smallest value. So 2.3762, 1.2165, and 3.6625. Well, this here is the smallest value right here, sulfur. So what I'm going to do is I'm going to divide each number by the smallest number. So now I'll go over here, I'll divide this by 1.2165, and I'll divide this by 1.2165. And let's see what we get as our answer. So this one in the middle, sulfur, is going to be equal to 1. And what about this value over here? Let's go back to our calculator. Let's go 2.3762 divided by 1.2165. It's going to be 1.953. And let's go over here and let's do oxygen now. Let's clear this. Go to our calculator. 3.6625 divided by 1.2165. My answer is 3.011. So now we're a little bit closer. Now what I can think about the final equation as being something like this. H 1.953, S 1, O 3.011. And you can see that this still isn't quite right. These still aren't whole numbers. The sulfur is a whole number, but the oxygen and the hydrogen aren't. Now this is where students, I often find, get a little bit sort of confused or a bit unsure about when we're able to round these values up to whole numbers. And it's a little bit of a common sense approach, and it's a little bit of an experience approach. The more you do these, the easier this becomes. We're actually able to round this value here, 1.953, and this value here, 3.011, to the nearest whole number. We can do that. And so what I'm going to do, I'm going to remove this, because this is not our final answer, and I'm going to say so I'm working over here now with my hydrogens. 1.953 is approximately equal to 2. And if I come over to my oxygens, 3.011 is approximately equal to 3. And when are we able to do that? Well, I say when we're anywhere between, when the range, when this value here is 0.1 off a whole number, we're able to round it up or down. So this is 1.9, so it's about 0.1 off a whole number, so we're able to round that. And the same over here, if this is 3.1 or anything less, we could round that down to 3, which is what we've done. So now what I'm able to do is I'm able to write the complete final empirical formula. So the answer will be H2SO3.